Let's check the molecular orbital theory for N2 molecule. Nitrogen electronic configuration is 1s2, 2s2, 2p3. Another nitrogen element electronic configuration also 1s2, 2s2, 2p3. When these two nitrogen atoms combine each other, they will produce N2 molecule. How they can combine? Through their atomic orbitals, they combine each other and they will produce N2 molecular orbitals, and resultant N2 molecule will form. Let's check how they combine each other. Nitrogen atom combine each other, produces N2 molecule. Nitrogen atom electronic configuration. Lower level is 1s2, next level is 2s2, another level is 2p3. Higher level. This is the energy. So coming to the another nitrogen atom, 1s2, 2s2, 2p4, 2p3. Sorry. When s orbital combine each other, they produce two number of molecular orbitals. One is bonding, another one is anti-bonding. So bonding molecular orbital is sigma 1s, anti-bonding is sigma star 1s. In the same manner, 2s orbital combine each other. They produce two number of molecular orbitals. One is bonding, other one is anti-bonding. Bonding is sigma 2s, anti-bonding is sigma star 2s. So next, combination of 2p orbitals, 2p3, 2p3. When p orbital overlap each other, as I said in the previous example, when p orbital overlap each other, one sigma bond, two pi bonds will be generated. So p orbital combine each other, one sigma bond and pi bond will be there. In the same time, anti-bonding also, sigma and two pi bonds are there. Here if we can observe 7 electrons in nitrogen, 7 electrons in another nitrogen atom, 14 electrons are present in N2 molecule. When 2p intermix each other, in ground level, pi px, pi py will be there, because total number of electrons in the molecule are 14 or less than 14 are present. The system will contain in the lower energy pi px and pi py. Sigma bond will be higher energy than pi bond, sigma 2pz. If the electrons are more than 14 in the molecule, then sigma bond will be lower energy, pi bond will be the higher energy. That is the rule, remember it. And then now next level is pi star 2px and pi star 2py. Final energy level is sigma star 2pz. Sigma bond will split into, the energy in between the sigma bond is very high than pi bond, because sigma bond is very stronger than the pi bond. That is also remembered. So now let's fill the electrons. According to MOT, what are the bonding molecular orbitals? Sigma 1s, sigma 2s, pi px, pi py and sigma 2pz. What are the anti-bonding molecular orbitals? Sigma star 1s, sigma star 2s, pi star 2px, pi star 2py, sigma star 2pz are the anti-bonding molecular orbitals. Next, now energy levels of the molecular orbitals. These are the energy levels. Lower energy is sigma 1s, higher energy is sigma star 2pz. And then coming to electronic configuration. Let's check the electronic configuration. How electrons are present in those orbitals. That is the electronic configuration. Let's check it. So here 2 electrons are there. In this orbital 2 electrons are there. Both of them intermix each other, and 4 electrons are there. that 4 electrons will occupy, first 2 electrons will occupy in sigma 1s because of lower energy, then another 2 electrons will be occupied by sigma star 1s. So sigma 1s, sigma star 1s2. Next 2s, 2s, same. 2 electrons are here, 2 electrons are here. Total number of 4 electrons. 2 electrons will be here, 2 electrons will be there. Then 3 electrons, 3 electrons. Total number 6 electrons. 1, 2. Because of these two orbitals are having the same energy, so that electrons first one by one occupies in the same energy level orbitals. If more electrons are there, then they will be paired up according to Hund's rule. So now extra electrons are there, so that electron will be paired up here and here also. Now 4 electrons are finished, remaining 2 electrons will be there. That 2 electrons will be here in sigma 2pz. Fine. Now let's write the electronic configuration. Very lower energy, sigma electronic configuration. Sigma 1s2, next level, sigma star 1s2, next level, sigma 2s2, next level, sigma star 2s2, next level, pi px pi py is equal to pi py. Next level, sigma 2pz, next level, pi star 2px, pi star 2py, next level, sigma star 2pz. This is the electronic configuration. Let's fill the electrons. Sigma 1s2, 1s2. So electrons are there. Here 2 electrons, here 2 electrons, here 2 electrons, here 0, 0, 0. This is the electronic configuration for N2 molecule. Next, coming to other point from MOT is to find out the bond order. Bond order in N2 molecule. Bonding electrons minus anti-bonding electrons divided by 2. So how many bonding electrons are there? What are the electrons are present in bonding molecular orbitals are the bonding electrons. What are the electrons are present in anti-bonding molecular orbital are the anti-bonding electrons. So bonding, sigma 1s2 bonding, sigma 2s2 bonding, and next pi px pi py bonding, sigma 2pz also bonding. So 5 bonding orbitals are there, 5 into 2, 10 electrons are there. In anti-bonding, sigma star 1s2 2, sigma star 2s2 2, and here no electrons are present in p orbital anti-bonding level. So 4 electrons are there. 10 minus 4, 6 by 2, 3. So means that in between nitrogen, triple bond is present. Triple bond is present. Stability. Stability will be calculated by the ratio between bonding electrons and antibonding electrons. Bonding electrons are more than antibonding electrons, so this molecule is stable. Sorry, one more point is there, magnetic property. So all paired electrons are there in this molecule, so that this is diamolecule. In case any unpaired electrons will be there, then that will be paramagnetic. But in this nitrogen molecule, all molecular orbitals are having paired electrons. So this molecule is diamagnetic molecule. N2 is diamagnetic. Fine. So this is the molecular orbital theory for N2 molecule. Let's go for CO molecule. Let's check CO molecule molecular orbital theory. CO. Carbon is one atom, oxygen is another atom. Let's check in the same manner. Here carbon, here oxygen. In carbon, so here this is CO molecule. Carbon atom 6 electrons are there. In oxygen atom 8 electrons will be there. So 6 plus 8, 14 electrons. Total number of electrons also 14. So now carbon 1s2 electronic configuration. Let me write the electronic configuration for carbon atom. 1s2, 2s2, 2p2, is the electronic configuration for carbon. Coming to oxygen, 1s2, 2s2, 2p4 is the oxygen electronic configuration. Now, 1s orbital of carbon, 1s orbital of oxygen combine each other, they produce two number of molecular orbitals, that is sigma 1s, sigma star 1s. Same manner, 2s orbital combine each other, sigma 2s, sigma star 2s will be produced. 2p3, 2p4 of oxygen, p orbital of oxygen, p orbital of carbon will be participate in the bonding, and they produce the same molecular orbitals which are present in the nitrogen molecule, because CO molecule also having 14 electrons, N2 also having 14 electrons. 14 electrons or less than 14 electrons are there. Pi bond will be lower energy, sigma bond will be the higher energy than pi bond. That rule you remember it. So now the same electronic configuration will be there, and bond order also, electronic configuration is same, bond order also same. So bonds present in between carbon and oxygen is C triple bond O. Stability also same. N2 is diamagnetic. CO is diamagnetic molecule, because all paired electrons are there in their molecular orbitals. Fine. This is related to CO molecule. N2 is homonuclear molecule. CO is heteronuclear molecule. In the exam, if they mention, write the molecular orbital theory for heteromolecular molecule. If they ask like in that manner, you have to write CO molecular orbital theory. If they ask, write the molecular orbital theory for homonuclear molecular orbital, then homonuclear molecule, then you can write the N2 molecule or O2 molecule. Right? Let's check O2 molecule molecular orbital theory. MOT for O2 molecule. MOT for O2 molecule. See, I'm just modify some molecular orbitals from this molecular orbital diagram. How O2 will be there compared to CO. Let's check it. Oxygen 8 electrons, oxygen 8 electrons, O2 will form, then 16 electrons will be there. Now 1s2 lower energy, 2s2 higher energy, 2p4 is the more higher energy than these two. Electronic configuration of oxygen, 1s2, 2s2, 1s2, 2s2, 2p4. Another oxygen, 1s2, 2s2, 2p4. Right? Now, so 1s, 2s same. Coming to 2p, 2p4, 2p4. 4 electrons, total number of 8 electrons. Now, only here, remember this, for O2 molecule, lower energy will be sigma bond, sigma 2pz, and the higher energy will be pi px and pi py. Remember it. So because here more than 14 electrons are present in this molecule, so that very lower energy is sigma 2pz, higher energy than sigma 2pz is pi px, pi py. Then antibonding is same as it is, which is present in N2 molecule and CO molecule. As it is, antibonding order will be there, but only thing is that here changes will be there because of 16 electrons, more than 14 electrons. So now let's fill the electrons. Here 4 electrons, here 4 electrons. Very first 2pz will occupied by 2 electrons, and then pi px, pi py will be occupied by 4 electrons. Then 2 more electrons will be there. The 2 more electrons will be present in pi star 2px, pi star 2py. Fine. Pi star 2px, pi star 2py. Now electronic configuration. Let's check the electronic configuration. Electronic configuration: sigma 1s2 less than sigma star 1s2, sigma 2s2 less than sigma star 2s2. Then the bond will be sigma, molecular orbital will be sigma 2pz. Here little change will be there. Let's check. Only changes I'm telling. sigma 2pz2 less than pi px2 is equals to pi py2. Pi px2, pi py2. Same energy. Lesser than. Now same. Pi star 2px, one electron is there. Pi star 2py, other electron is there. Then highest energy will be sigma star 2pz, 0 electrons will be there. Now coming to the bond order. Bond order. So bonding electrons minus anti-bonding electrons. How many bonding electrons? Bonding, sigma 1s bonding, sigma 2s bonding, sigma 2pz bonding, 3, and pi px, pi py also bonding orbitals. So total 5 bonding orbitals. Total number of electrons are 10. But coming to anti-bonding, in anti-bonding, sigma star 2s2, 2 electrons, 1s2, 2 electrons, sigma star 2s2, 2 electrons, total 4, pi star 2px1, pi star 2py1. So total number are 6 electrons. Here anti-bonding electrons are 6 by 2. So that the answer will be 2. 4 by 2, 2. Means that in between oxygen and oxygen, double bond is present. Double bond is present. Okay. Stability. This is less stable than N2 and CO molecule because anti-bonding electrons are more than bonding electrons. Compared to N2 CO, there are anti-bonding electrons are only 4. But here 6. If anti-bonding electrons are increases, then automatically stability decreases. So compared to those two molecules, this is little unstable. Fine, that is the stability. Then O2 molecule is, tell me, paramagnetic. Why? Because of in pi star 2px and pi star 2py anti-bonding orbitals, there are 2 unpaired electrons are present. Because of these unpaired electrons, this molecule is paramagnetic molecule. Fine. This is of O2 molecule. These examples are very much fine for you, and 2 more examples are there, 1,3 butadiene and benzene.